I've connected to a different network now. Okay. Good evening, everyone. Once again, I'm Shivesh Sharma from Quality Council of India, and I extend a warm welcome to everyone present today for this session on new and renewable energy. Udyog Manthan is a marathon of focused sector-specific webinars on promoting quality and productivity in Indian industry. It is an initiative of the Ministry of Commerce and Industry, supported by Quality Council of India, National Productivity Council, Bureau of Indian Standards, and industry chambers like CII, FICCI, and ASSOCHAM. These webinars aim to draw in best practices and experiences of sector and industry experts to identify challenges related to quality and productivity faced by Indian industry with a view of solving them to promote vocal for local and ultimately Atmanirbhar Bharat. Before we begin, the following is requested to everyone. All participants are requested to turn off their video and stay muted till the end of the discussion to avoid any ambient noise. A participant may unmute only when prompted to ask a question. Alternatively, a participant may write their questions, if any, in the chat box, which will be announced by the moderator or chat monitor. The speakers are requested to switch on their camera while they speak. With this, I'm pleased to introduce the moderator for this session, who happens to be Dr. Ashwini Kumar, who is working at TERI as Senior Director, Renewable Energy Technology Applications since November 2017. He is leading the division with a wide range of activities pertaining to policy, research, accelerated dissemination, and capacity building in the area of renewable energy. He has worked for over 26 years in Ministry of New and Renewable Energy and dealt with various programs in different capacities. He has been engaged with development and implementation of National Solar Mission in the ministry. Dr. Kumar obtained his doctorate degree in solar energy from IIT Delhi in 1981. He has co-authored 3 books published by international reputed publishers, several review articles, over 50 research papers in peer-reviewed journals. I now hand over to Dr. Kumar to take forward the session. Over to you, sir.
Thanks, Sevesh. First of all, good afternoon to all the dignitaries, the key speakers, participants. I would like to congratulate the Ministry of Commerce, supported by, in their efforts by Quality Council of India and all the organizations, for bringing focus on this very important topic of quality and productivity. With that, I would like to introduce our context setter, Dr. Bijendra Singh Negi, who happens to be my colleague earlier, and he is a dear friend. He is from IIT Delhi in 1989. He is working presently as advisor in the Ministry of New and Renewable Energy. Dr. Negi contributed to bringing out policy guidelines for research, development, and demonstration program, and more specifically, the lab policy for testing, standardization, and certification for quality control in renewable energy sector. He has contributed to bring out technical regulation for SPV system, devices, components as compulsory registration order under BIS Act. He has published 50 research papers, including 25 papers in international journals, and he has presented many in various seminars, workshops, and he has contributed to renewable energy development in India in seminars and all. He is responsible presently for preparing policy and guidelines for quality infrastructure for RE sector. So over to Dr. Negi. Yeah.
Thank you, sir, for introducing me to the participants. I will also begin with congratulating Ministry of Commerce and Industry for this wonderful step, and for Quality Council of India for excellent coordination in organizing this event, and for inviting me to participate in this event. I'll start with, am I audible there? Ah, is it okay?
I would request all the participants to mute their microphones so that there is no interference. Yeah.
Yes, so I'll just I'll start with a brief background about the growth of renewable energy in India, and then I will come to the theme of the event selected for this workshop. So India, witnessed tremendous growth in renewable power, particularly in SPV power, last 5 years in its effort to ensure 24/7 sustained energy supply to its people linked with climate change mitigation. This achievement is attributed to the government initiative in 2015 to scale up deployment of renewable power to a capacity of 175 gigawatt by 2022, which includes 100 gigawatt solar power as follow-up to the Paris Agreement at COP21. As a result, the share of renewable energy power in the total installed generation capacity has increased from 6.47% in 2015-16 to 23.5% in 2020-21, thereby attaining global position at number 4 in the renewable energy deployment. Out of total installed renewable power generation capacity of 91.5 gigawatt as of now, solar has achieved cumulative 36.9 gigawatt, which is largely based on import of solar cells or SPV modules and inverters. Wind power installed capacity is 38.62 gigawatt. The abrupt eruption of COVID-19 pandemic in early 2020 and subsequent disruption due to lockdown gave devastating experience of globalization, making everyone turn towards national in their orientation and to reduce dependence on global supply chains for their needs. Effectively, we need to develop and manufacture technologies, products indigenously for our needs. From the experience and recognizing the vast potential of SPV power deployment, the government is aspiring to achieve 450 gigawatt capacity from RE by 2030. Looking at global experience, huge investment on technology development and innovation have played a key role in fast, widespread deployment of solar power across the globe. The SPV technology is developing fast. Currently, efficiencies of SPV modules in the range of 20 to 22% have been reported by the lead manufacturers. Wind power technology is also developing fast. Atmanirbhar Bharat is an important step taken by the government of India for strengthening and augmenting manufacturing capabilities and capacity in the country. For solar PV, the recent launch of the Performance Linked Incentive PLI scheme by the Government of India for high-efficiency SPV modules is a great step to boost domestic manufacturing of high-efficiency SPV modules in India. It gives ample opportunity to Indian SPV industry to invest on R&D for technology development and development of production technology, scaling up its manufacturing capacity for SPV modules with quality at global level. Looking at the perceptible large market in India, export potential, and the rich experience, the industry has to gear up its efforts, mobilizing investment and collaboration with lead overseas manufacturers for development and manufacture of high-efficiency advanced solar cells and modules. Another area of key importance is battery storage. PLI has also been allocated for battery storage. Now I come to the point, quality and productivity, which is the main issue for discussion in today's seminar. It's wonderfully selected team, which is going to be of significant importance in achieving the objectives of the MNRE as well as the GOI. Quality and productivity are both measures of performance and ends of economic development. Quality effectively implies whether the product produced is in accordance with the predetermined specifications or for compliance to the needs. Quality control means to ensure that the product meets the requirements and quality standards which are set. A good quality product meets consumer expectations. Productivity is a measure of efficiency of production activities. There is a third term called safety, which improves quality and productivity. Safety is essential for smooth business. 2. Thus, safety, quality, and productivity have to be integrated for successful operation of plants or business. Quality improves safety and productivity. Therefore, standards need to be followed for maintaining quality of the products. You all are aware, India has set a dream for $5 trillion economy by 2025. A robust quality infrastructure is essential to achieve the dream. The MNRE is the first institution in the country which brought out a lab policy for testing, standardization, and certification for renewable energy sector in 2017. Subsequently, Department of Commerce brought out an action plan for standardization, which was followed by policy guidelines for lab recognition by BIS. A renewable energy standardization cell has been set up in MNRE for review and development of standards for various renewable energy technologies, systems, components. MNRE is following IEC, ISO, Indian standards in programs related to solar, wind, and SHP. For solar, MNRE on 5th September 2017 notified technical regulation for quality control of SPV modules, inverters, and battery storage. As per the said order, the products should conform to conform to specified Indian standards. As of now, around 250 manufacturers have got registration from BIS for their products, which includes SPV, mostly SPV modules, very small number for inverters and battery storage, after qualifying specified Indian standards in BIS approved test labs. Around 53% manufacture are from domestic sector. This provides ample opportunity to domestic manufacturer to scale up their manufacturing unit in collaboration with foreign partners. COVID-19 lockdown disruption period was effectively utilized by MNRE for perusal of development and implementation of standards. Standards should be easy for understanding and efficient delivery of testing services. A draft standard on battery storage, including lithium-ion battery, was developed by MNRE and was transmitted to BIS for further necessary action. Standards on SPV modules and inverters have been perused. In this context, MNRE in November 2020 brought out guidelines for one standard for one product, inclusive of all testing requirements following international standards and incorporating Indian climatic conditions, and recommended the same to BIS for further action. A draft standard on grid type SPV inverter is under process for transmission to BIS for further action. One standard for one product will facilitate efficient testing and certification services, and hence ease of doing business in the country. Sufficient experience has been gained in quality control. The objective now should be to ensure quality and productivity at production level. effectively domestic manufacturing in all sectors of renewable energy, particularly in solar and wind, in large volume with quality at global level needs to be encouraged. This will require huge investment by private sector for innovation and R&D for continuous technology development and development of production technology to meet the country's need as well as for export. The effort will open up ample job opportunities in the country. To achieve the above, indigenous manufacturing within the provisions that the government have created, and of course to fulfill the aspiration of the government to utilize maximum potential of renewable energy, will require the quality in solid, robust quality infrastructure as follows. I'm just listing out the points which we will discuss. These are the issues which needs to be addressed, and these opening establishments will also create job opportunities, which is also another important objective of the government. First of all, extensive consultations for standard development and updation. Second point, transparent and efficient process for conformity assessment of test labs for specified standards followed by approval by BIS. Third point, adequate numbers of test labs, both in private and in government sector, including public-private partnership mode for efficient and reliable testing services, which will also create job opportunities. Fourth point, calibration facilities, which is essential for accurate determination of the performance parameters. For fifth point, monitoring of intercomparison of test results of test labs to ascertain consistency of test results. Sixth point, robust process for performance certification. Seventh point is robust process for assessment of manufacturing unit. And last point is just a kind of signaling, chalta hai attitude should not be allowed. So when we talk about robust quality system, no scope for chalta hai, because every test results, the accuracy in test results will give the credibility of the performance certification and hence to achievement of the targets set by the government. That's what we thought that we can discuss with the lead experts available in this group. That's it, sir.
Thank you, Dr. Negi. It's a really very, very important which is given by the ministry through you, and very well defined 9 points say, because I think I would like to stress that what is mentioned by Dr. Negi is more relevant, because now if you see that renewables has emerged as the electricity source of choice. I mean, there is no now compulsion, because you see the prices of electricity, solar and wind has breached the thermal power tariffs. So that's the choice together. And if the targets which are mentioned by the government have to be achieved, the systems has to survive for their, I would say, the contract periods, which is the PPA period of 25 years or something. So it means the system has to be of highest standard. So all efforts from all are required in that, from the industry, from the lab infrastructure has to be there, very transparent, reliable, timely, and I would say what the various developers, I think, would like to look at, not very costly. So that's because the cost has become very, very important in the Indian market. With these words, I would like to take this opportunity again, thanking Dr. Negi for bringing out, for setting the context. And now I would like to invite various speakers looking at the time. And I think the organizers have indicated that they would like to keep good time period available for discussions. So I would like to request all the speakers to limit their interventions from 5 to 6 minutes kind of time frame, because then we would be left around 40-50 minutes for discussions. Because I see about participants are already coming in, has come in, so there should be a good interesting discussions around all the topics. With this, the first speaker is Dr. Chun Su Lin, who is a research fellow and deputy director, Center for Green Economy, Chung Hua Institution for Economic Research, Taiwan. Dr. Lin was an associate researcher with the Institute of Environment and Resources in Taipei. Recent and concurrent research topics of his interest are focused on the issues of resource recycling systems, soil and water pollution abatement systems, green trade, green industry development, and circular economy. He has also served as Secretary General of Green Trade Project Office under the Ministry of Economic Ministry to promote the trade and exchange of green products and services internationally. Basically, he is a doctorate. He obtained his doctorate in environmental and natural resource sciences from Washington State University, USA in 2001. So over to Dr. Lin.
Okay, thank you. Thank you. It's my honor to meet everyone here online. I'm joining from Taipei. By starting my PowerPoint, I would like to share a few slides in PowerPoint with you. Okay. Okay, so everyone see it? Can everyone see like the slides here?
Not yet.
Not here yet?
Not yet. Not yet. Mr. Sivesh, can you help him in slides?
If you allow, sir, I can. Okay, yes, we can see the slides now.
Yeah, yeah.
Please continue.
Okay.
Okay. All right, so you see the PowerPoint, right? The PPT already.
Please continue.
Okay, all right, good. And okay, it's I know this webinar is about how we develop renewable energy and at the same time how we maintain the productivity and the quality. So I would like to share some challenges and strategies in Taiwan in the past several years. And here is very brief introduction about my organization. It's a think tank in Taiwan, a leading think tank, and we are established in 2013 in the CIER, which is established in 1981. And here is some status of Taiwan green energy, and this is just published last year, at the end of last year, about how Taiwan is doing in terms of green energy. And so you can see we were very sorry, and we were ranked at 57th out of 61. And looking at India, India is actually doing very well. You are on the top 10 list. So what's the problem with Taiwan now? I think a few questions here we have been discussed a lot. For example, we don't have a very good policy, overall comprehensive policy, but no green policy at all for post-COVID period either. But we have a very strong ambition. We like to reduce 50% of carbon emission by 2050. So there are a lot of schemes used in Taiwan, including FIT, the feed-in tariff for renewable energy. And 2025 is a very critical year for Taiwan because the government tried to make Taiwan a nuclear-free homeland by 2025. And how we can achieve that? And mostly we have to increase the portion of power generation from renewable energy up to 20%. And also we have to force the big companies and consumers to use renewable energy at least 10% by 2025. So in this regulation, they have to install renewable energy facilities or buy certificates or install energy storage, etc. If they cannot fulfill anything from the top 3 options, they can also just pay some fees. Okay, the fees to cover what they should do. Okay, and here is a renewable energy FIT scheme. And basically, it's a surcharge. The money is from a surcharge from fossil fuel electricity generator into a development fund. And the development fund is used to subsidize utility company, it's Thai power company in the center of the slide here. And it's a state-owned monopoly company. And they can get, and they also use the money to do some promotion, R&D, auditing, and demonstration work, etc. And here you can see we have some targets for different different renewable energy types, especially for solar PV and also offshore wind. And these are 2 major options in Taiwan. So the government is trying to develop these two options, but there are quite a few questions and difficulties in front of us. And for example, and mostly we are familiar with the ground-mounted type of the facility, but in Taiwan we have to develop rooftop for the buildings on the buildings, or rooftop on the parking lot, or some floating types of solar PV. And more importantly, here are 2 examples about symbiosis with agriculture and aquaculture. Okay, the left-hand side is a facility built on some fishing pond. Okay, fish farm. It's a fish farm, and on the pond, and you can build up the solar PV also. And on the right-hand side, it's a facility over cropland. So these are 2 major concern for us, and but the government try to develop these 2 options because we don't have too much land in Taiwan. So in total, the ground-mounted PV is only about 1/5 of the total installation in the country, and we rely on the rooftops a lot. So the concern for the productivity of the symbiosis of solar PV and agriculture or aquaculture, there are a few issues. The first one is the income sources for farmers. The farmers can get some money from FIT, okay, because they are selling renewable energy. Also, they can also do the harvesting on fish crops. But there are some. Okay, so the coverage of the limitation for the solar panels on the facilities, and also how we can maintain the productivity as before from agriculture. And the other option for Taiwan is offshore wind. Okay, and Taiwan is an island. The offshore wind are also very important, and they are mostly located on the west side of Taiwan. But in the past several years, okay, from a lot of developers coming in from international society, especially from Denmark and Canada, also from Germany, and they have a lot of installation capacity here in Taiwan, but they have to obey a rule in Taiwan. The rule is you have to localize the industry in Taiwan, offshore wind industry. So you not just develop your facilities, you also have to help the development of industry in Taiwan. So here come to conclusions. The first one is in renewable energy development in Taiwan is still a long way to go. And we have a lot of problems with legal issues, or land availability, or livelihood of farmers, etc. And the second one, I think, is more important. The purpose of renewable energy development should be clarified. We are doing this for carbon emission reduction, or we want to develop a new industry, or how we can maintain the productivity and upgrading the productivity at the same time. So the purposes have to develop. So then you have a different strategy in Taiwan. But right now in Taiwan, we are not so clear about this. And from the scholar point of view, and this is very important because they have different strategies. And the last one is the comprehensive framework is necessary for this society. Okay, that's about my presentation, and thank you.
Thanks, Dr. Lin. It's a nice presentation, and I think I would request all the participants to collect their questions, put in the chat box, because we'll have a very vibrant question and answer session in the end. Now, I take this opportunity in inviting Dr. Anjan Ray, who is the director, Indian Institute of Petroleum, which is one of the flagship laboratories under our Council of Scientific and Industrial Research. He is a doyen in his domain. He did his doctorate in chemistry from the University of Pennsylvania under the guidance of Nobel laureate Professor Alan McDermott. He then moved to chemical industry and worked for over 25 years across functions ranging from quality control, technical services, R&D and marketing to general management, mergers and acquisitions, and corporate strategy. His professional interests have spanned fields as diverse as surfactants, oleochemicals, lubricants, coatings, adhesives, textiles, cosmetics, pharmaceuticals, water treatment, energy efficiency, biofuels, and renewable energy policy. He also leads the supply chain vertical of the CSIR strategy group constituted in March 2020 for developing CSIR's concerted response to the COVID-19 pandemic and to the transformations necessary in the post-COVID world. Over to Dr. Ray.
Good afternoon. Thank you, Dr. Ashwini Kumar, for the kind words. I hope I am audible. Are you able to hear me clearly?
Yes, sir. Please go ahead.
Thank you. I would first like to thank the organizers for inviting me here, and particularly to the speakers who spoke before me, Dr. Negi and Professor Chunshu Lin, for setting some very important context here. As, for example, Professor Lin said, land is a challenge in Taiwan. It's a country I have visited many times. Remarkable how much progress it has achieved with limited locally available resources. And I have personally learned a lot from Taiwan's progress. The point you made about using solar photovoltaic as a canopy for aquaculture and agriculture is something we are looking at closely as well. However, with regard to today's specific brief on quality and productivity, already I think Dr. Negi covered these points. Dr. Negi covered these points admirably. And quality, as we know, is a prerequisite, fitness for purpose in the eyes of the customer. Productivity is linked to asset utilization, both capital assets and manpower and resource assets, and safety and environmental impact, including end-of-life considerations, underpin quality and productivity issues. I have been very privileged to have been part of MNRE's journey for many, many years. From its inception, a leadership role in identifying and addressing core issues through policy interventions and schemes. The Ministry of Consumer Affairs and BIS has ably supported these efforts. That said, I want to expand the scope of today's discourse from renewable power, which is being equated often with renewable energy, to renewable energy in a much broader context, covering not only power, but fuels and heat. Because ultimately, if you look at India's total pool, it is not only power that drives our carbon footprint. It is not only power that drives our resource utilization. And in that context, let me pause and talk about PV, and then get onto the matter of standards for PV and wind. So we know that today, if I have to put solar modules and I use either rooftop or ground-mounted solutions, I either have land-based challenges or maintenance-based challenges. We've also heard about the limited local manufacturing capabilities, particularly on the side of cells. And we have also heard about the issue around high-quality storage solutions. My personal belief is that in India, hybrids are likely to be a much more effective solution than very intensive storage, because storage itself requires land and it requires a degree of sophisticated technical capability, both on the quality side and the productivity side. Whereas, let's say, a wind-solar biofuel or a wind-solar biogas hybrid requires zero storage and can be grid connected for both directions. So I would personally be very excited about prospects of seeing hybrids start proliferating much more quickly. And these are also significantly more scalable today because of the Satat biogas scheme that has been brought out by the Ministry of Petroleum and the MNRE support to biogas-based power generation. India, it turns out, imports 350 million tons of carbon atoms every year in the form of petroleum, coal, and natural gas. And then we blithely throw away 500 million tons of carbon atoms. Similarly, I could suggest that Taiwan do a bit of carbon atom counting. Every country could benefit from this, because it actually tells you how much we can be import independent if we supply chains and on effective local utilization of waste resources. For instance, today in Pune, inside the Katraj municipal dump, we produce pipeline quality or engine quality bio PNG from municipal solid waste and municipal wet waste. In Dehradun, we collect 1 ton out of 20 tons of the plastics that are thrown daily. And from that 1 ton, we produce 800 liters of diesel. So I could picture a future where gensets are completely taken to waste fuel produced energy. And we eliminate fossil fuel powered energy to gensets. These kinds of interventions could get us very quickly to meaningful scalable interventions on the carbon reduction side as well as the carbon localization side. And now coming to the aspects of standardization, biofuels are getting standardized quite extensively by BIS. As are renewable power components, we already heard how the Government of India PLI scheme encourages SPV industry in India to focus on R&D for technology development and deployment of modules. Dr. Negi mentioned that. And to make brand India viable in this level, we probably need our standard to catch up even further. There's quite a lot of effective work being done on the side, as well as wind turbine side. We have standards. We have something like standards for wind turbines issued by BIS. But if you can start these towards hybrids, especially biohybrids, we would be the world leaders in standards for integrated hybrid power generation. These do not currently exist anywhere in the world. Also, issues of certification that have plagued industry and where industry have raised a lot of questions at various forums. If we move to hybrid models and we certify the quality of power rather than the quality of generation. So we look at power uptime, we look at power availability, we look at the power factor, we look at the power reliability. Ultimately, the end user wants power. So the installations can be certified based on components, but the grid, the ability for somebody to buy the power, make it bankable, make it reliable, would be much more effective if we start developing hybrid power standards. I will leave it at that because I know there are many other learned speakers ahead of me, but I would be very happy to answer questions or participate in a later discussion on the matter. Thank you.
Thanks, Dr. Anjan Ray. As usual, very inspiring. And I would like to add a line that what Dr. Anjan Ray has indicated, that's really the very good intervention, that one way of looking of RE intervention is through the RE power. But I think the thermal application, the heat application, that's another very significant part. If you just look at the industry, about 50% of their total energy consumption is in heating. So that requires, and I is going to come in there in various routes. And one of the very important route, what has been mentioned, is the Satat scheme, which provides the CBG, basically compressed biogas, and that opens up a market kind of economy for CBG. So that's a testing ground. So that, I think, that will open up this channel. Again, thanks to Dr. Anjan Ray. Now, I would like to invite again dear friend Dr. Arun Tripathi, who is Director General, National Institute of Solar Energy, which is one of the 3 specialized institutions of the Ministry of New and Renewable Energy, located just at the border of Delhi and Gurgaon, the place called Gwal Pahadi. Dr. Tripathi has worked in MNRE in various capacities, and he has handled various major projects such as grid-connected rooftop, small solar power plants program, energy efficient solar green buildings, development of solar cities program, village electric energy security projects, information and public awareness program, waste to energy program, planning coordination, national program of biogas development. And he is BSc Engineering, MEMTech, PhD from IIT, MBA Environment Management. He is leading the National Institute of Solar Energy as one of the premier institutions in maintaining quality, what we are talking today. So over to Dr. Tripathi.
Thank you very much, sir, and a very good afternoon to all of you. I am very happy that I have been given a chance to interact with the learned participants and the speakers in this direction. Sir, in fact, I thank Dr. Negi. He has really set the tone and he has focused. He is the leading for the quality development in all RE sector. And so MNRE has already taken a lead in making the quality, maintaining the quality. So I would like to mention few of my thoughts on various issues of renewable energy development in the country, basically focusing on the topics which are meant for today. In fact, the manufacturing, what I feel personally, the views being given here are the personal views, and I feel that the manufacturing sector has not been given the required impetus, especially in the field of renewables, as it should have been given over the last 25 years. We somehow have been depending ourselves in foreign imports, in getting the things done by other countries, and behaving like a consumer only. So this has resulted at present that we are lagging behind in the manufacturing sector. Now the time has come. There is no choice before us. If we do not avail this opportunity, we will really lose for a very, very long period of time, which we have already lost had we started giving impetus to the manufacturing at least 20 to 25 years ago. So we have to change our approach from being consumers, mere consumers, to becoming the manufacturers also. And when I say manufacturing, there are certain period of time people say that it's not profitable only because we compare with certain things available and we import it from the nearby countries. So my first suggestion is that Ministry of Commerce and all the people who are responsible for making the manufacturer a lucrative system, making the manufacturer an attractive system for the industry, should come forward, raise their voices in whatever manner they can raise before the highest authorities of the ministries or in whatever manner. Second thing is that when I call the manufacturing system, means we must get a complete chain to be manufactured, complete chain to be done. Say, for example, of a PV, at present, more than 80 to 90% things we are importing. Even if the modules we are assembling, more than 80% things we are importing. I was very surprised to know, I recently had a visits to many of the industry, and I came to know that even the small things are being imported. Even the nut bolts, even the frames, which can be done very easily, they are being imported. So we should, Udyog Manthan ka matlab ye hai ki we should really have a thinking, a rethinking where we are going wrong. The second thing is that once we, since the whole country at present, I would say the solar sector, let me talk about the solar sector. The other experts can speak about the wind and others. As far as solar sector is concerned, we are, of course, again, we are only concentrating on the economic sense in the development of a sector. And we have completely lost the track of solar thermal system. Solar thermal system, we are only going in the gigawatt system by installing the PV system, that's all. That is the solar sector today, which the India is facing. And Dr. Ashwini rightly said that we have a huge potential of the process heat, which cannot be met by the PV sector. But all the manufacturers, it really pains me when I see many thermal manufacturers have converted themselves into the EPC contractor, or they are importing the systems and selling it here because they do not find the right regime, right environment, right policies to promote this sector. So once we go for the manufacturing system, we should promote all these sectors. We should make congenial policies. We should make the systems available for so that we can take care of all these the sector as a complete. Have we ever thought that why we are lagging in our system? Still today, an industry has to go more than 18 to 20 types of approvals. Still today, whatever we call. So regime has to be the industry friendly. There are many people, we have the capability, we have the funds, but many times the regime doesn't permit us to go for the industrial development and the manufacturing development. I'm sure that those who are listening, I'm really sorry for being a little blunt, but these kind of issues are still remaining. They are restraining the industry to come forward. Second thing is the land. Of course, that's a major issue which cannot be tackled in a single system. But land is also an important issue which needs to be, if you go, it needs to be given, it needs to be made available at different by different system. I do not know what system has to come. Power system, the reliability of the power and the quality of the power. It has improved a lot in our country over the last 1 decade, I would say. But it is yet to take off. It is yet to improve as far as the industry installation is concerned. Suppose a solar PV module, I'm talking about the module is manufacturing in a unit. If the power shuts down, the person has to leave a loss of more than 70 to 80 lakh rupees in an hour. You can imagine the system. that the power, how the power is important, the quality of the power is important, assurance of the power is important. And in many of the industry, first they have to do the DG based power set, because we do not have any other option. So you can imagine the amount of cost and the environmental degradation which a DG based power set takes place. So power quality has to be improved. These are the basics for giving the manufacturing sector a boost in this direction. The third thing is the low cost of the funding. Of course, it has a many other impacts but the cost of funding is really, really very high in our country. That is why the industrial people, industrialists are they are fine get from many other places. But in our country, the manufacturing sector. So until we do all these things, it is really difficult to boost this sector. Taxation, of course, many measures have been taken to give the
Hello.
Please continue, sir. Yes, sir. Please continue.
Yeah, please continue.
Hello, am I audible?
Yeah.
Hello.
Dr. Tripathi, yes, continue and conclude, please.
Yeah. So, hello.
Hello.
Audible?
Yeah.
Okay. Sorry. So this has to be given, and there are certain areas which I would like to point out. The one point was the taxation and the duties. The country has different priorities, and these have to be seen in the overall development of the country. But certainly, for giving a special impetus to the manufacturing, these things have to be certainly given a consideration by the respective authorities to lower the duties, to lower the taxes for manufacturing sector. And there are certain areas where we can really, as far as the solar development is concerned, the storage is one of the area where the lithium-ion battery. Now they are finding the applications in electric vehicles also. So in the regime of electric vehicles, this manufacturing has to be given a special thinking, a special status for manufacturing. Otherwise, we will be importing from other countries and nothing else. Now, the next thing is that I come to the quality system.
Dr. Tripathi, we need to conclude. Sorry for We can't hear you right now. Yeah. Dr. Tripathi, can you hear us? Hello. I think we have lost him out.
Sir, it seems that we have lost him. Yes, sir. Yes.
Yeah. Okay. So can I thank him? I don't know.
Yes, sir. I think we can move ahead.
Okay.
Yes.
I would like to thank Dr. Tripathi for very bold, I would say, interventions. And I think that needs a bit supplement of information as a moderator, which I would like to do, that when he talks about manufacturing, I think he's focusing on me. If we go beyond that, like for example, the wind power, 80% is the domestic content, that everything is done in India, and wind industry has come out over the last 30 years in biomass, in various other technology, even solar thermal. I think everything was done here. So I think it's a mixed bag. So we should not look at only solar PV, but certainly, as the previous speaker, Dr. Anjan Ray, mentioned, the hybrids is the way forward. With that, again, I think many of the points can be discussed by the participant through question and answer session. I would like to invite now Mr. Partha P. Chatterjee, who is the CEO, Environment Energy Services Private Limited. Basically, Mr. Partha Chatterjee is a corporate think tank and an accomplished strategist. A stalwart in the energy management industry, he has been part of the Environment Group since last over 15 years and has led the organization to its present prominence. With 31 years of experience in diverse industry and business segments, he continues to lead Environment to its growth path. Mr. Chatterjee has completed his PG DFT from Symbiosis IMS and Masters in Business Administration from Pune, and has a background in mechanical engineering. So over to Mr. Partha Chatterjee. Yeah.
Hello, I hope I'm audible. Thank you so much, sir. Good evening to all. I hope I'm audible.
Yes, go ahead, Mr. Partha.
Okay, great. Thank you so much, sir. It's been a real privilege and a pleasure to be part of this discussion panel. I thank Dr. Negi sir, we know him for a long time. Ashwini sir, know him for a long time. Since the inception of the
Partha have some problem with the network. I think we are Mr. Partha Chatterjee.
Am I not audible? Hello.
Now you are audible, so I think we lost you in between. So
I see. So, anyways, once again, sir, I am really grateful and privileged to be part of this panel of discussion. Ashwini Kumar Saab, we know for a very long time since the inception of the industry. Dr. Negi Saab, and now we are at the crossroad whereby the Indian industry as well as the country as a whole is looking at how to kind of be Atmanirbhar for our own industry to kind of lead the global requirement. Sir, I think I'll not speak much about the quality side since Negi Saab and Ashwini Saab all are there. It will be audacious of us to talk about standards and other thing. We would like to talk about certain basics, and I echo the thoughts of Dr. Anjan Ray as well as Dr. Tripathi to some extent, whereby I think quality and productivity, these are intertwined. So in the sense, there is enough incentive for a manufacturer to focus on quality because the advantages are many. Like we basically have the lesser failure of components, the output is much more pronounced, like these are the differentiators, and it has advantages like minimum failure, low warranty and replacement cost, enhanced customer satisfaction, funding opportunities, etc., etc. So given an opportunity, I believe all the agencies and businesses will try to adopt to the best quality practices available today, as the advantages are well known. Now, how to kind of invite everyone to a journey whereby we become the global leaders in quality as well as self-reliant in our own technologies. So presently, since as we have already identified that most of the capacities are kind of getting imported, I'm talking about the PV industry. So if there is certain incentive in terms of technology, which technology to be chosen, which will be kind of giving us the best results as far as the manufacturing lines are concerned, if there can be some kind of guidance from the industry bodies that will be helpful for the manufacturers to take an informed decision. And basically automation is also key for ensuring that the quality is uniform and human errors are minimized. So, but then this automation also comes with additional capital requirement. So there the funding gets prominence, whereby certain countries like China and all, they have an advantage. Why? Because the cost of fund is quite low there. And also the other incentives that are there for the industry to set up. So for example, while China started around 15-20 years back, they already had certain domain expertise in semiconductor, and 6-7 corporates were the leaders there as on date, where basically we kind of graduated from their semiconductor experience to the solar PV area. So we need some kind of a support there, whereby we can have these relevant inputs, and we can set up world-class facilities. Of course, scale is also very important, because ultimately setting up a facility where cost of production is high makes no sense, as Ashwini sir also mentioned, because we have to be very focused on having the right kind of cost structure, so that the product is acceptable, the solution is acceptable. The second point, what I also echo the thought of Dr. Anjan Ray, as he has rightly mentioned, that the quality of power, because today we have a lot of standards on the components, and how we can kind of look at the installation and overall performance. So if there can be some kind of performance benchmarking, I think Eminari has a lot of data from various installations all across the country. So how do we kind of incentive, how do you kind of recognize the performance and incentivize them, can go a long way in ensuring quality installations and quality output throughout. As regards the standards are concerned, there is this BIS certification which has been introduced. This has really kind of, I think, helped in standardizing a lot of products. But I think that this standard is also, I think, a bit outdated, in the sense, if you are talking about the IC standards presently, this is based on 2016 edition, and that might be looked into.
हाँ यार ये इसका है ना, मैंने तुमको कई पेपर आज भेजे, तुम गए नहीं, आप इन तक गए नहीं अगर यहाँ हो तो।
Sir, am I audible? Hello. Yeah. So
Yes,
another
please
issue.
continue.
I hope I'm audible, sir.
Yeah, continue, please.
Yeah. So another issue which was also voiced by many module suppliers or manufacturers is the use of RFID to track each PV module unit. The practice is presently more expensive compared to the barcode labels and all, but might have been outdated also as well, because it was introduced to track subsidy grants, which may not be available as on date. So it is imperative for domestic manufacturers to focus on the quality of solar equipment, so that they can perform in long run for 25-30 years. It will also help to get the domestic and international funding for good quality projects, and improve manufacturing efficiency. R&D is one area where I think already a lot of discussion is happening about. So if industries can pull together their budgets and have R&D, common R&D facilities, because individually we may not be able to contribute much, but if you can have some kind of arrangement, informal or formal, on pooling of resources, this can really help. And as regards the impact of COVID, I think the impact of COVID-19 on global trade has been really very visible, with reduced trade flows and collapsing demand across the globe. The most severe impact has been on the global as well as regional production networks, as supply chains around the world were disrupted. In the post-pandemic situation, countries are expected to reshuffle their supply bases and increase dependence on local production. Countries such as Japan are paying cash incentives to their companies to bring their production networks back home. India also has been urging industries to make their supply chains local. The Prime Minister spoke of an Atmanirbhar Bharat and a self-reliant India to lessen India's import dependence, and at least for those products that can be manufactured locally. So while the idea is noble, its successful implementation would require an assessment and necessary upgradation of India's indigenous production capacity by directing investment into the right channels. So implementation of the vision, actually we have a lot of good strategies and vision that has been placed in front of us. Now I suppose the implementation would be the key, and if we all come together to ensure that we have a robust implementation method in place, this will really do a lot of good for the industry and the country. And this particular budget also, we had quite a few incentive. I'm not getting into the details, maybe that can be part of the discussion. So now the need of the hour is to harmonize our efforts and see how we can come out as a winner in this critical era where the Industrial Revolution 4 is being talked about. Thank you so very much. Thanks everybody.
Thanks, Mr. Partha Chatterjee. You have made really good points. I now take this opportunity to invite Mr. Balram Mehta, who is a pioneer chief. He is the chief operating officer of Renew Power Private Development, which is the largest, I would say, RE company in the country. Mr. Balram Mehta has overall 27 years of experience. He started his career with DCM Engineering Products. He remained there for 11 years, and then he entered the wind energy sector with Enercon India Limited and in 2003, and was responsible for O&M of southern states. Subsequently, he worked with CLP India Limited as Vice President Operations, responsible for the construction and O&M of CLP India's wind portfolio. Over to Mr. Balram Mehta. I would request, you are a veteran, and make your key points. I think some of the things are spoken already, but I think I am expecting from you very, the burning points. Yeah.
Sure, sir. Thank you. Thank you. So I think most of the speakers, they have covered the solar portion very well, and I'm sure the future speakers will also cover the solar portion. But wind, which is a backbone of the Renewable Energy Initiative by Honorable PM and MNRE and the concerned ministries. So we have the advantage. I'll not go here and there. I'll come to the point. Wind has an advantage over solar. That is a kind of very matured setup. Like it's a 30-year-old industry in India. Very matured, internationally well acclaimed OEMs, IPPs, and well established, well oiled supply chain, well oiled ecosystem. And if we want to correlate with the quality, we can say that the kind of restriction which were there, that until the machine has the type certificate, I think that was the major gist of quality. So you can combine many standards, but the kind of the strictness with which it was implemented, especially the type certificate, and it has ensured that even the machines are 25 years old, but they are still working. I'm not commenting on the efficiency, but as far as design, safety is concerned, the machines are still in operation. And wind sector, the other plus point with wind sector is that is absolutely made in India. 80-85% products are manufactured in India. It's only like 10-15% which we import. And it has caused a huge employment creation in the form of OEMs, and OEMs are not assembling. It's like blade and all these this small section which I'm telling, they're very labor intensive. Blade, tower, nacelle, casting, gearbox, generator, EHP line, substation, and project execution, civil work, OMS, security, whatever you want to say, it is covering a wide skill level required and wide coverage. And the most important is if you see the wind farms, wherever we have installed the wind, those are at a very remote locations. So we construct the motorable roads which are easily accessible by all guys in that area. And through CSR, it creates it as like whole shape of those sites, those villages have changed. If you want to see the progress, and many villages personally I know from Maharashtra, Karnataka, Gujarat, Tamil Nadu, like the complete shape has changed. It's only because of the availability of wind and installation of wind farms in that area. The other plus point with wind is that it actually meets the peak period requirement. It's available whenever the energy is required as per the Indian system. Now, challenges, I know there can be a complete list, but I will like one is the payments. If we see the 38 gigawatt what has been installed, except the last one, which is with the NTPC or SECI or with discounts. So payment is an issue which I think for the survival of the sector, it's very important we streamline that. Thanks to the central government, MNRE with continuous intervention, they come out with schemes, but unless we find out the permanent solution to ensure that discoms survive on their own, I think we come out with a scheme. The scheme is valid for 2-3 years, then again the cycle repeats. And other, I think land was touched upon a little bit, but I think as per since for the last like 17-18 years I'm there in the sector, there is a mismatch in the understanding between the central government, the speed at which the central government wants to go, and the speed at which the state government wants to go. And land is a state subject, which is critical. Like speeds are not matching. So I request that if through various associations with the ministry, if we can ensure that they understand the urgency of deployment of renewable for energy security, it will be good for the sector. It will be good for the overall initiative. And third point, which I want to highlight is in India specifically, we are not valuing the green component of energy, whether we produce through solar or through wind. We are again comparing it with normal fossil power. So that's very important. We have to compare it and we have to give that due weightage because of the green component. And as I told that because of the restriction and type certificate, it's good that we have a very good control as far as equipment quality is concerned. And then if you see the current, I shouldn't say it, these are my personal views, but then the tariff reduction, the rate at which we have reached, the level at which we have reached, is a kind of putting a pressure on all IPPs to cut corners here and there, somehow to make the project viable. So we also have to see whether the tariff whatever are being discussed are viable or are we compromising anyway. A machine, as I told, we can't compromise. So finally, we are compromising on land, we are compromising on structure, we are compromising on evacuation system. That has to be seen. And the fourth point which I want to highlight is in the auction strategy, it's only the big IPPs which can participate. Whereas the sector has been driven by small investors. If you see out of 38 gigawatt, 28 gigawatt belongs to the small investors. Like there are examples in Karnataka, Maharashtra, Tamil Nadu, 1 machine, 2 machine, 2 megawatt, 5 megawatt, the small IPPs, small investors. So we have to bring them back in the loop. And if you see, there is hardly any addition from those investors, which were backbone at one point of time. And finally, I can say that we have all the facilities, the ecosystem is available, the skilled manpower is available, and we can make India as a manufacturing hub in the current scenario. It only needs a push. And then finally, as Dr. Anjum Roy has said, that if we are able to combine wind, solar, and some storage system somewhere, whether it's a battery or whatever you want to have, then I think that's the future for India. If you see standalone wind is not the future, standalone solar is not the future, but it's a beautiful combination of wind, solar, and storage somewhere. And I think for energy security and to have self-reliant on energy sources is very important. We start thinking that. Thank you, sir.
Thanks, Mr. Mehta. Thanks, Mr. Mehta. It's really very good that you came to the point straightway and very important inputs. Now, I would like to invite Dr. YBK Reddy He is Additional General Manager, Solar Energy Corporation of India, and he has wide-ranging experience working in solar PV, in solar thermal as well, and he has completed his PhD in 6 CIGS, thin film solar technology, and he uh, basically he's working as AGM at SECI and taking care of technical aspects of all type of solar PV system projects and storage, solar wind hybrid projects, solar radiation measurement and forecasting studies. Dr. Reddy, there are already some questions and concerns. I, from my side, would like to get your reaction being at SECI, that what pinches you, like in terms of the quality, productivity, and what remedial measures you would like to propose? Dr. Reddy, is he there? Sivesh, is he there?
Sir, I can't see him in the list of the attendees, sir.
Okay, maybe I move to then next one.
Yes, sir, you may move. In the meanwhile, I'm trying to establish connect with him, and I will let you know.
Okay. So in the meantime, I would like to move to Dr. Narendra Siratkar. He is Assistant Professor in charge, PV Reliability Group. And this is one of the, I would say, ambitious Center of Excellence set up by Ministry of New and Renewable Energy called National Center for Photovoltaic Research and Education at IIT Bombay. And as far as concerned to Dr. Shiratkar, he is a reliability man. So he works in the area for setting up the procedure, processes, protocols, and standards, basically, and he works on accelerated testing protocols. So prior to joining IIT Bombay, he worked as a photovoltaic research engineer at Jabil Circuit, USA for 3 years. And before that, he obtained a PhD in electrical engineering from Florida Solar Energy Center after graduating from IIT Bombay, doing BTech, MTech in microelectronics. So over to Dr. Narendra Shiratkar. Yeah.
Thank you for the kind introduction. I'm audible, right? Can you hear me?
Yes, sir, please go ahead.
Okay, good. Thank you. All right, so I'll keep it short because we are, I think, sort of running a little bit late. Yeah, as it was introduced, I represent IIT Bombay and also NCPRE, the National Center for Photovoltaic Research and Education, which was set up in 2010 by MNRE. And for last 10 years, MNRE has generously supported this National Center of Excellence, and we work in a broad range of areas such as thin film, new materials, crystalline silicon, solar cells, high efficiency solar cells, energy storage, power electronics, and of course reliability and education. And we have a quite interdisciplinary team over here, about 30 faculty members from 9 different departments and about 150 student and staff working towards the deliverables of NCPRE. Dr. Negi mentioned the importance of high efficiency solar cells and modules made in India, and also about storage. Since I work in reliability, I would like to also make a case that there is another way to differentiate products made in India, okay, and that could be the reliability and durability of the solar cells and modules made in India for the Indian climates. And I'll tell you why it actually makes sense to design products specifically for Indian market. Okay, the current 61215 type of standards published by IC and their BIS equivalents, those are initially designed for moderate climatic zones. Okay, and even in those climatic zones, they don't assure a 25-year lifetime. They are just design qualification standards. What we have seen though in our all India surveys of PV module reliability conducted jointly with NICE is that these modules degrade at much higher rates in Indian conditions, okay, the hot climate that is typically seen in India. Now, the financiers assume a degradation rate of about 0.7% per year, and we have seen an average degradation rate which is significantly higher than that, close to 1.4% or so per year. Okay. Now, we did not see. Obviously, this is a challenge, right? That the modules are degrading at a much faster rate, but this can also be an opportunity. I'll tell you why this is an opportunity. This is because we did not see any particular trend that modules from this particular country, domestic or foreign, are degrading at a lower or a higher rate. It was sort of mixed. Okay, it really depends on how the module is designed. There was no correlation as such. But what we would like to say here is that if you understand clearly how the modules degrade in Indian climatic zones, there are key degradation mechanisms that are there in such climatic zones, then you can actually design a module that is more robust to those failure at degradation mechanisms. And that module would then easily be able to differentiate itself from other run-of-the-mill kind of a PV module, which is made to be deployed anywhere in the world. I'll just give you 3 examples of that, and then I'll conclude. Okay. First one is the qualification standard itself. All modules that are here that are being deployed in utility scale power plants or even commercial and residential rooftops, they are 61215 or BIS equivalent qualified. Okay. Even if you take the latest 61215 standard, that does not assure a 25-year lifetime because it doesn't qualify modules specifically for the hot climates. Now, over the last few years, we have been very active in an IEC task group, and we were working towards development of a new standard which would be for qualifying modules in hot climatic zones. This standard is called IEC 6. It was recently published in 2020. So I don't know if there are any modules that are now qualified using this standard because it was very recently published, but this is an opportunity, especially for module manufacturers to qualify their modules as per this standard, because this standard can clearly qualify a module for hot climatic zones that are typically seen in India, and then the product can be from the rest of the modules which are just 61215 kind of qualified. Second thing we have seen is soiling is a big problem in India. We have seen soiling rates of the order of 0.4% per year, okay, soiling loss. Per day, 0.4% per day. So you can imagine if the module keeps soiling for a few days, its power is going to be about 50% or so in no time, right? So anti-soiling coatings have been proposed as one of the solutions because the anti-soiling coatings would either repel the dust or they would make it easy to clean the solar panels. However, what we have seen through our studies at NCPRA is that the coatings perform well initially at time equal to 0, but the coatings are not reliable at all. They degrade, lose performance just in a matter of a month or two in the climatic zone of Mumbai when we are cleaning those coatings, right? So it is important to benchmark or identify a reliable. If you want to really sell your panel as a dust repellent kind of a panel, and we have actually developed a set of test procedures that you can help that you can use to perform a reliability benchmarking of different anti that are available in the market. We have also designed an instrument where you can test out different cleaning methods, different types of brushes, rotary or linear brushes, as well as different anti-soiling coatings in our cleaning and soiling simulator, and we can basically do some sort of a lifetime prediction as to how long a particular coating will last in an accelerated test or in the field deployed conditions typically seen in India. And the third thing I would like to mention is that the other problem which we have seen is cell cracking, right? You can have a very nice module, but if its cells are cracked during transportation or installation, the modules tend to lose power over time. And how much power they will lose and whether they will lose power is actually, it's a very subjective thing. There are some places in Europe where people have seen cracked cells in the modules, but they haven't lost any significant power. On the other hand, we have seen in India that modules with cracked cells tend to lose power over time. And it was very difficult to really predict what will happen to a power plant, let's say if it goes through a hailstorm or something happens, which results in cracks, right? So we have designed a setup here at NCPRE now, and this is, by the way, a completely indigenous setup designed at NCPRE, and it can actually help you predict the worst case power loss a module can experience due to cell cracking. Okay, in other words, and in simple words, if you have 3 or 4 different types of module designs, you can test those out in this setup, and we can identify which module is more tolerant to cell cracking, okay, or which module would lose less power due to cell cracking. This can be useful in deploying solar panels in locations where you want to protect against cell cracking. Let's say rooftop PV modules where there are issues due to wildlife such as monkeys and other stuff, okay, around the modules, or you cannot control the deployment of the module. The transportation, the roads are bad, etc., etc. So these are some of the things. So I think these few things that I mentioned, those can be used by Indian module manufacturers to differentiate their products and their product designs, specifically for Indian market, because Indian market is going to expand in solar, and Indian climate is actually quite unique. And this is actually, I would look at it as an opportunity instead of a challenge. So I conclude. Back to you.
Thanks, Dr. Narendra. I want to just mention at this point that there are two, at least I know that coatings which have been developed indigenously. One at the PSG College, Coimbatore, and that coating they have tested in field, and I think that's there. Another is by, I think, ARCI, Hyderabad or somewhere. Two coatings have been developed, but I think your points are deserves special mention. I think Dr. Negi is there, who will be taking these forward. I take this opportunity now in inviting Mr. Harsh Vardhan Govil, which I think many of the participants are waiting for interest, because he represents the Adani Solar, where the manufacturing of solar cells modules happens. Mr. Harsh Vardhan Govil is the Chief Operating Officer there, and he looks after cells and modules manufacturing. He is having a strong orientation in business excellence, operational performance, profitability, process re-engineering, cost analysis, reduction control, digital support, and reorganization. Prior to Adani, Mr. Govil has held executive level positions with industry leaders, namely Vikram Solar, Moser Bayer, SRF, and CEAT Group. Not taking your more time, so over to Mr. Harsh Vardhan, giving some tips on manufacturing, why it is not happening or why it is happening. Yeah.
Yeah, thanks a lot. I hope I am audible.
Yeah.
Yeah. So I will just take the audience through a short discussion on why actually quality and productivity take a not just a backseat, but they run through a pain area for every manufacturer in the country. We have seen that the country's fiscal response during COVID-19 has been very effective, sizable, timely, and immediate. And that is why, despite the GDP loss that we have seen in 2021, we have been able to come out unprecedentedly fast. And thanks to all the initiatives announced by the government, there is a lot of focus and impetus, and there's a movement in the market on expansions and new capacities coming up, for not only for the mainstream cells, modules, and many other components in the supply chain, but also for the upstream and the raw materials. But what is while quality becomes increasingly important as the future of energy sees a renewable demand going up by 10x, there are certain things which still pull us down. The first and the most important, all of you would have realized, is that the PV industry is facing a technology-led interception, wherein as the manufacturers pull up to set up high-speed equipment for manufacturing, very low footprint, wherein you could replace 1 gigawatt equipment straight away with a 2 or 2.5 gigawatt, and cell sizes going up. In fact, the wafer sizes going up. Today, there is a challenge put forth to the Indian manufacturers by the Chinese counterparts in terms of 182 and 210. That is what the industry talks, and all the expansion projects in India. Even though India, completely manufactures only multi-product, the entire future seems to be on the higher size of the cells. So as the cell sizes increases, the module size also goes up. Going forward, the demand is going to be completely on the bifacials. So this would mean a glass-to-glass configuration would be important. A heavy product, fast-moving machines, high-density modules. You see, there is a race to improve efficiency and reduce LCOE. That's what the customer wants, and that's what is going to help the industry too. So all this poses a very demanding situation for the industry, wherein it has to cope up with the speed of execution, the speed of ramping up the facilities, and trying to rope in skilled resources, which could really make it happen. Now, the country doesn't have these skilled resources. So each of the manufacturer hires a lot of resources from the market, trains them, and then it takes a lot of time, and there is a attrition too. So what comes out very clearly that the country today needs institutions dedicated to training structure or courses on renewables, be it solar, be it wind, or other means of renewables. Since solar occupies a larger portfolio and wind too, so that's why I'm talking of specific courses in the institutions wherein this could help the industry at large. The second important aspect is that Chinese have consolidated their supply chain to source quality material consistently for a longer time, which is not the situation in our country. We are scrambling frantically to find and source raw materials for ourselves. Sources from China are not ready to even supply material under advance payments. Freight charges have increased phenomenally, somewhere 4 to 5 times. And also, there are limited avenues left to the Indian manufacturer to source the material. Anti-dumping duties are therein, which is for the benefit of the investors in India, but the Indian manufacturing space as it is does not have a complete supply chain. So what do the people do? They run to tier 2, tier 3 manufacturers. Even with the surge in prices, there are certain compromises on the quality of the raw material and hence the product, which many of the manufacturers tend to somehow compromise and survive into this challenging scenario. So this is one thing wherein many of our earlier esteemed speakers have mentioned about Atmanirbhar and all. Our debt rates have to go down further, while the PLI scheme offers very good advantage in terms of setting up new facilities. But the debt rates, unlike China, still remain high, and we need to have a very strong outlook here, wherein longer tenures and cheaper debt rates could facilitate things to happen, at least on the upstream manufacturing. I would say as we progress from a component level situation in any project, we move on to module, to cells, and to wafer, to ingot, and to polysilicon, the manufacturing gets increasingly complex. And such a type of manufacturing does not invite investment from many of the possible, or rather, let's say, probable investors in the country. And this creates a scenario wherein public sector needs to strongly intervene or incentivize the industry for upstream manufacturing. These are very power intensive and skill intensive industries. So this is one part that we need to very strongly look into. I would run through one just last point. We have been talking a lot about R&D. In fact, the country has been really chasing in on Chinese to establish and adapt ourselves to whatever Chinese have been throwing into our country in terms of technology. And leave alone raw materials, even the kitchen secrets to maximize production and sustain the best quality levels, they are missing with us. We try to source these inputs through people, some of the handful of people who are there in the industry. There is no mechanism by which Indian investor is supported on these aspects. So R&D, we have been talking that there are grants or there are aids. I think not just leaving it to a private sector, R&D should be promoted through government interventions into renowned institutions of research in the country, and it should specifically look into aspects of solar or PV-based R&D, which could take us ahead of the rest of the countries in terms of a forecast on where our technology and industry needs to go. Our equipment manufacturing for solar is completely sourced from China. So the engineering too has to go a long way. If the R&D for the process and the product comes in, engineering will easily follow suit, because India definitely carries a very good base on engineering. So there are manufacturers in China and in many labs across the world which run golden lines to run a prototype for futuristic products. In India, we never do that. Neither that is promoted because the risk is very high. We tend to be very low risk investors, and we definitely then will trail behind Chinese in every aspect. So the demonstration capacities need to be built up in the country with wherein we can demonstrate and work upon futuristic technologies like HJT and tandem and others, and could establish for ourselves what exactly could be the scenario in terms of building efficiencies, quality, and productivity. So this is what I would summarize here. And this part of the capability or capacity demonstration for futuristic products, if this gets incentivized by the government, it will go a long way in facilitating R&D in the country as a joint venture between public and private investors. So that is all I would like to say on quality and productivity, because fundamentally on the ground level, standards and everything will control quality. But truly speaking, the industry can control quality if many other inputs are available to it and easily available, rather than being a compromise. So thanks a lot for giving me this opportunity. And I hope since the time is short, I think I have done some justice to what I'm supposed to speak here.
No, thanks, Mr. Govil. It's a nice intervention, I would say, and many key recommendations have been made by you. And definitely one of the very important recommendation is relating to the raw materials availability ecosystem. In fact, I am aware that when Adani plant was being built at Mundra, that all the whole ecosystem will be developed there. But I don't know, it has not gone the way it was planned. Policy initiative on rationalizing duty that can help in that. apart from that, the R&D, I think that's the key, because even if you buy a solar manufacturing line, start manufacturing, but there is a need to continuously upgrade the process, and that can come only through intellectual minds. I think there is a need to look at that the intellectuals can be, related to a particular manufacturing facility to help the industry in maintaining the upgradation, enhancement of the quality and all. Probably that's the kind of recommendation. And then demonstration of new and emerging technology. Of course, ministry has been doing a lot, but I think still there is something more need to be done. So thanks for that. Maybe I am coming to our the last speaker, Mr. Deepak Jade. He is the head power utilities and renewables SGS India. He brings with him 20 years of rich experience helping businesses and institutions embrace a more sustainable future. Demonstrated history of working in management, consultancy, project testing, verification, inspection, certification industries. He is a mechanical engineer with Master of Technology and Chartered Engineer by qualification. So over to Mr. Jade. Yeah.
Thank you, Dr. Ashwini. It's my pleasure to be on this particular August platform. Thank you very much, Ministry and Quality Council of India, for organizing this much needed webinar series. I'll be sharing a brief presentation with all of you. Can you see my screen?
Not yet, sir. It is there, sir. You can go ahead.
So I would like to share brief facts about this sector. Like India has taken a global leadership in renewable energy, and Government of India has challenged itself to surplus 175 gigawatts of target by 2020. If we look at globally, RE installation, CAGR, for top 5 or 6 countries, we rank first with 16% CAGR. However, with this ambitious renewable energy targets and global supply chain needs a legally bound long-term quality assurance program. That is something that we need to ensure to honor our power purchase agreement. At the same time, life of a particular renewable energy project, it's a solar power plant or wind power plant, runs from 25 years to 30 years. So durability of the various products or equipments used in the product are extremely important. On the market side, all of us are knowing that tariffs are reducing, which ultimately pushing a pressure on the cost and quality. Insurance claims are rising day by day globally. And with these two scenarios, lenders are prioritizing quality as one of the strong point in providing any financial assistance to a project. Operationalization or harmonization of international technical standards like inspection, testing, certification can reduce this risk to a large extent and actually outgrow technological improvement. Manufacturers, as all the speakers are saying earlier, all manufacturers are moving towards new technologies. So technology standards needs to catch up with this new development. TIC industry, testing, inspection, certification industry, from which I come to, has around 70% from the renewable sector. So this is one of the important sector even for TIC industry. Quality and productivity, as Dr. Negi has already spelled out in the first session, it really has quality has direct impact on productivity, direct impact on the safety, which ultimately leads on the lifespan of a particular plant. Most of the renewable energy projects in India, we have plant load factor ranging between 13% to 22%, and they are really not generating power as per the original designs. major issue being quality. So incremental 2% plant growth factor will naturally have additional revenues, and it will reduce the payback period by almost 10%. On the right-hand side, you will see a graph, product quality versus productivity. Naturally, if the product quality is poor, productivity naturally will be poor, which ultimately has poor design, safety, maintenance are poor, and the project may not run throughout the life cycle. You can have product quality, good product quality, but still the productivity could be lower. So that means the design is not proper or maintenance practices are not being done properly. On the top, this is the good area to play with. We have highest productivity, highest product quality. In this case, we can always explore high-end potential like artificial intelligence solutions to optimize or improve power operation. So renewable energy is about the performance of a project, not just the installed capacity. And quality and productivity will help us to improve and sustain the performance from a solar power plant or for even a wind power plant. SGS is working in the field for quite some long time. So based on our past experience, a few case studies, like we did 25 gigawatt of module inspections in the past during production. So these are some of the case studies which shows almost 50% reduction in the defects by undertaking a proper production inspection at a module manufacturing facility. Second case study could be transportation. In fact, most of the defects on modules happens during transportation. So this particular chart shows if you take the same transporter, different manufacturers, you have variety of EL defects. Even with the same manufacturer, different transporter, again we have various percentage of EL defects. Third and last case study is on the installation. Like you have a good product at site, but installation also needs to be proper at site. So you can see one installation group putting up 4 to 5 different projects. Again, the EL defects are varying from as low as 0.5% to as a 6%. So this indicates that quality has to be maintained throughout the value chain of a project. Like typically we have 3 stages of a project, let's say design stage, procurement stage, installation and operation stage. So if you want to have the proper optimum productivity from a particular project, we need to ensure quality during each stage. Further breaking down, we have conceptual stage to design, manufacturing, transportation, and installation and commissioning. So we need to integrate our quality system in each of these micro stages. Let's say for a first conceptual stage, whether we are having a realistic project schedule and cost estimates for a project. Most of the times quality are compromised because of unrealistic project schedules or cost estimates. Second, on the design part, apart from technical design, there has to be integration of ISO 15001, 14001, and ISO 9001 to ensure that the entire value chain is energy efficient, environment friendly, and we have quality systems in place. Whenever we are procuring any product for a project, whether that product has a product certification in place, whether the manufacturer has the capacity to produce that kind of product in a given timeline, factory audits, quality assurance plans, so on and so forth. Transportation, as I was mentioning to you earlier, it's one of the key bottlenecks for having defects. So whether we have clear-cut guidelines for transporter, that also needs to be ensured. Then once we are at site, quality assurance plan, health and safety plans to be inbuilt in the project, and that has to be vigorously implemented. And the installation agency should have trained manpower to implement, erect the project. And during operation phase, of course, we have to integrate effective operation and maintenance practices, and artificial intelligence-based performance tracking also can be integrated to ensure we are continuously monitoring the performance vis-a-vis taking the remedial actions. In India, we have quality standards in place, like the The circles show variety of quality standards for various technologies like for wind turbines, solar modules, inverters, so and so forth. On the right-hand side, a table shows the best global practices. Like in India, most of our standards are for product. We need to also give importance on selection of a manufacturer, installer selection, commissioning, and performance of a power plant. So we have IEC standards for all these very critical stages, and we need to inbuild all these good practices during the project cycle to ensure overall quality management. Last slide, suggestions. As I mentioned, most of our standards are product level. We need to integrate workmanship issues at the ground level. Second, responsibility of adaptation enforcement of standard as of now largely lies on the DISCOM, state nodal agencies, banks, or project developers who may or may not have the requisite skill. So one of the suggestion is commissioning certificate can be issued post complete technical conformity assessment, and for which there could be suitable framework developed or competent agency can issue that by ensuring that project has followed all the technical standards. Last but not the least, information dissemination. Whatever best practices we have adopted in the past, that needs to be disseminated to various stakeholders. There could be education curriculum and training programs can be organized so that learnings from a particular project can be effectively implemented in subsequent projects. That's how we can make the overall ecosystem more quality conscious and productive. Thank you very much. Thank you for patient hearing. We'll be happy to answer any questions.
Thanks, Mr. Deepak. Very nicely articulated some of the very key points. I think at this we come to the end of speakers' interventions. I don't know whether Dr. Reddy is there or not, but I don't see him in the list, so that's why I think we can go to the question answers. And I am looking at the clock also. I think, I don't know, Mr. Chairman will tell how much time we can devote, but I think already there are a few questions and I would like to raise those two questions. In fact, one question is already answered on the chat box. The question was, will solar energy equipment face a restriction of material? Some materials are restricted by European environment norm in future. So I think that is answered, that environmental compliances in any way will be the consideration technology selection, and this is not about EU regulations alone, but about the future of our planet. So I think these considerations are going to be there in these standards. Maybe I would like to point out that another the factor which is doing the rounds is about the what will happen to end of life modules. So whether that should also be made a part of a standard somewhere, or of the procurement procedure, that the OEM, they should buy back those materials. They should try to recycle that, extract the energy, and also all those kind of issues are there. So that question is answered, I think. But there is another question from Mr. Yash Kumar Katrodia. Sorry, but Dr. Negi, would you like to say anything on that? The environmental compliances in the standards or norms, if you want to supplement that information any further. You have to unmute, Dr. Negi.
Sir, you have clarified that, each standard specifies the requirement of the equipment. So if there is a compliance that has to be done, there is a need for compliance that has to be done. Am I audible to you, sir? Hello, am I audible to you, sir?
Yes, sir.
Audible to you?
Yes, sir. We can hear you. can hear you.
So you have clarified that point, sir.
Okay. No,
you
thanks,
clarified.
Dr. Negi. I thought maybe you would like to, but
No,
thanks.
that's very clear.
So I move to the next question. The question is from Mr. Yash Kumar Katrodia. What is the minimum investment required to set up the smallest unit of solar cell manufacturing plant in India? First, I would like to say something. Then I will refer this question to maybe Mr. Harshvardhan Govil, who is the from Adani Solar. He is having.
Oh, sorry, sir, for interrupting. This is Shivesh from QCI. It's a humble request to everybody to kindly mute their mics in order to ensure smooth conduct of this Q&A session. Please, thank you so much.
So, do I continue? Yeah. Okay.
Yes, sir, please. Please.
So the question was, what is the minimum investment required to set up the smallest unit of solar cell manufacturing plant in India? My take would be that you can't go for the smallest unit of solar cell manufacturing because that will be really not be cost competitive. So saying that, I think I'll refer this question to Mr. Harshvardhan Govil. But before that, I read the another question also. Maybe he is the best person to reply that also. The that question is
कॉन्फ्रेंस कॉल चल रहा है बट
this.
चलेगा.
Yeah. What is the comparative current manufacturing cost of polycrystalline and monocrystalline silicon solar cell in India versus China? So I think these two questions are from the Yash Kumar Katrodia, and I would like to request Mr. Harshvardhan Govil to say something on that.
Yeah, okay, please. As you partly mentioned it, correct, that
तो अगर माने कुछ अगर जा सकते हैं फर्स्ट क्लास में जाएंगे तो 4 बार नहीं है रथयात्रा হবে
I request that both
अक्टूबर तो अगर वो भी करना दिल्ली से है
Dev Mandal, if you can hear us, just mute your mic, please.
yeah, so so what I would like to say here is that in the current scenario, any capacity on cell manufacturing less than 500 megawatt would not be competitive and would face a very severe concern on the costing and from EBITDA level costing for any of the manufacturer who would like to venture there. And besides, as I mentioned in my discussion earlier, that 300 megawatt or 200 megawatt, these capacities are not available with the equipment manufacturers these days, and they would also not advise to go accordingly. So my take is 500 megawatt is a capacity which would be very competitive as a minimum scale. On the second question of comparative current manufacturing cost of polycrystalline and monocrystalline silicon solar cells, I would like to mention that this difference between the two. I think a lot of noise. The difference between the two amounts to somewhere 4 US cents, which would be a slightly higher in India compared to China, but the difference would remain the same. So I hope this answers the question.
Thanks, Mr. Harshvardhan. But I think, is it possible to give some ballpark figure? 500 megawatt solar cell
नहीं, लेकिन वो
manufacturing
शीट
plant
नहीं,
is
मम्मी
what
ने
is the
बात
kind of cost?
बिल्कुल नहीं पहना है इतने
2,000
टाइम।
crore, 5,000 crore, 3,000 crore, something like that.
See, I would mention it again that depending upon the
नहीं, मास्क
cost
तो
of
चाहिए, शीट हो
land,
फिर भी मास्क तो चाहिए। तो अगर
Please
प्राइस
mute
थोड़ा सा
yourself. All the participants are requested to.
नहीं, अगर पूरा बोगी अगर फर्स्ट क्लास टाइप बात करें तो पूरा अगर होगा तो उसमें क्या प्रॉब्लम? तो हम ही हैं। हाँ हाँ, उसमें भी
I would request all the participants to please keep their mic on mute mode, please.
वॉशरूम का थोड़ा कंसर्न हो जाता है।
Thank you.
yeah. So
थोड़ा सा
little
अगर मम्मी ट्राई कर सकती है जो हैवी वाले नहीं तो ये वही सर्जिकल वाले मास्क
She wears no, nothing happened.
वो जो N95 वाले वो पॉइंटेड वाले मास्क हैं, वो पूरे चिपके हुए भी नहीं होते।
Mr. C.S. Sharma is speaking. If he can mute.
वो भी ट्राई कर सकते तो उसमें पूरा मुंह पे चिपका भी नहीं होता ना, तो वो भी
CS Sharma is muted. We have Mr. Vikram Kotru. I can see that he is unmuted. I request all the participants to please mute their mics.
करते हैं बात मम्मी से।
Sir, please.
Yeah. Okay. So to clarify it slightly better, I would say that depending upon the cost of land and the cost of utilities, cell manufacturing facility would cost approximately in the range of 7 to 8 cents per watt peak. I mean, anybody can calculate from this figure what costs to put up a plant. Maybe it's half a gigawatt or 1 gigawatt, whatever the anybody would like to scale.
ठीक है।
Thanks. Any other questions?
Okay.
Sir, may I just try and understand? Suppose since this is a kind of a discussion,
वेबसाइट पे चाहिए या इसका मटेरियल चाहिए?
so maybe everybody can be also suggested to send their recommendations for any kind of policy matters, like how or what areas can be looked into.
अच्छा, सेल का प्लान चाहिए।
Sir, I think somebody is in the background.
अभी क्या-क्या products?
I think Shivesh, you need to have express powers to mute people around. A lot of disturbance.
The powers are vested with the DPIIT, sir. We can only request. I have already messaged him n number of times to mute him. There is one Mr. Vikram Kotru. I think that he has put his mic on unmute. Anyway, sir, please continue.
Negi sir and Ashwini sir, I was just wondering whether we can also send in certain note sheets, maybe just for the reflection, so that in case some points are pertinent, it can be deliberated upon.
In fact, that's a good idea, and I'll request Mr. Shivesh Sharma that he can request all the participants to send their suggestions and recommendations to him, which he can then circulate to DIPP or MNRE or the concerned ministries.
Right, sir.
That's
Thank
a
you,
good
sir.
idea.
Sure, sir.
Any other question? I would like to say that it has been a good interaction. A lot of points were raised or concerns were raised by the speakers, and definitely there is a need to develop a policy. The entire country is working on Atmanirbhar policy that has to be strengthened by these suggestions. And what we have learned, in the our solar journey or RE development policy through MNRE and all that, whatever could be done so far because of the government policy. In fact, government policy has been the biggest motivator or pusher for bringing this sector to the present stage. The work in lab has to that follow up it now, because if India wants to attain the leadership role, our scientists and our all intellectuals have to come forward to showcase their technology, superiority, and we need to work on that. What I would like to say on behalf of Dr. Negi, maybe he will say that ministry is always eager to work with all these stakeholders to do the right things, to bring out any policies, maybe on the recommendations on taxation and things like that also need to be done. What I would like to suggest that if one is the quality control. Dr. Negi has already pointed out that there is a big need of expanding that infrastructure, because if standards are there, guidelines are there, you need to do that in the field. So it means lab infrastructure, transparent mechanism, that everything has to be in place. But that's one part of the story. Second part is, if we want to go Atmanirbhar route and we want to do manufacturing, then how this manufacturing can be cost competitive, because that's the aim. If we are not cost competitive, there is no usefulness of setting the manufacturing units. And it means we need to do all that which makes Indian manufacturing cost competitive. So for that, the suggestions can be welcome from all the stakeholders, whether it is policy, whether it is demonstration project, whether it is capacity building, whether it is, signing, agreements with other stakeholders. So I think I would like to stop here. Maybe Dr. Negi can come in here and say his views. Yeah.
Thank you, sir. You have covered all important issues that have been deliberated upon, and of course your own views. I'm completely in agreement what you have said. Only one issue which I would like to respond to it through the query to Dr. Narendra Sariharkar from IIT Bombay. I just want to clarify why I mentioned about manufacturing of high efficiency solar PV module under production incentive PLI scheme. So in that PLI scheme, the objective of the government is to support to provide some incremental support for manufacture for producing high efficiency modules. So when I say high efficiency modules, means this will include the degradation part of the modules. So that will be characterized by power temperature coefficient. So when we talk about supporting high efficiency modules, it means not only efficiency, the other important component that is taken into account to determine the durability and overall performance of the product will also be taken into account. And we are taking this aspect into account in the revision of standards, where PID test will also be integrated with the other standards to determine the net efficiency of the SPV model after degradation. After degradation through various testing test sequences, which includes thermal cycling, damp heats, etc., etc. So I just wanted to clarify to the remarks given by Dr. Narendra. That's it, sir.
Okay, thanks, Dr. Negi. Over to Mr. Shivesh Sharma.
Thank you so much, sir. And I'm sure it was a very, very enriching capacity building session on NRE sector. People have really come up with their views and ideas vis-a-vis the implementation of the same in the country. I would request the speakers to kindly switch on their videos, the cameras, so that we can have a quick screen capture this session. And I would request my colleague Reeti to let me know when the screen capture is done, so that we can move ahead. Reeti, is it done?
Yeah, wait, just a second. Yeah.
Thank you so much, Reeti. So moving ahead with the vote of thanks. Now, first of all, I would like to thank you, Dr. Ashwini Kumar, Senior Director, the Energy and Resources Institute, for steering the deliberations so well and summarizing the discussions articulately. And then I would also like to extend our gratitude to Dr. B.S. Negi, advisor and scientist GMNRE, for gracing this event with his presence and setting up the context for this session. I would like to thank our illustrious panelists for deliberating on the issues of quality and productivity in the industry. And I request all the experts to spare some time and provide recommendations and suggestions in template shared with you, as this would help us in creating a compendium of quality related sectoral recommendations, which will be shared with the ministry. Furthermore, I would also like attendees for being such a fantastic audience. There were some technical glitches in, we all know it is a part of the game, but I really want to thank the attendees for being such a fantastic audience and being in this particular webinar, sharing their concerns and feedback in the respective form of communications established with them. Thank you so much, everybody. And here I conclude the session. Goodbye and have a great evening. Thank you so much once again.
Thanks. Bye-bye.
Thank you so much,
Thank
Mr.
you.
Shivesh.
Bye-bye.
It has been a pleasure. Thank you so much.
Thank you.
Thank you.
Thanks, Dr.
Thank you,
Negi
everybody.
Saab and Ashwini Saab. Thank you so much.
Thank you, sir. Thank you.